Okay, welcome back. Today we're working on section 4.1 of Intermediate Algebra, Martin Gay, 4th edition. Okay, and this is going to be about systems of equations, or in particular, two equations and two unknowns, which is quite common. And we're going to do the even numbers up to number 38. So let's start with number 2. First we have two equations, x minus y equals -4. 2x plus 10y equals 4. And then we have a pair, -3, 1. That's a pair, x, y. And what they ask is to determine if this -3, 1 is a solution to this equation. So what we're going to do is plug it in. On the first equation, -3 minus 1 is -4. So it is a solution to the first equation. On the second equation, that would be -6 plus 10 equals 4, and that is also correct. So this is a solution. Okay, now let's go to number 4. 2x minus 5y equals -2. 3x plus 4y equals 4. And they want us to check 4, 2. Okay, if we plug that in the first one, we get 8 minus 10, and that is -2. In the second one, we'll get 12 plus 8, and that's 20, so that's not correct. This one is not a solution. Okay, number 6 is y equals 6, x equals -2y. They want us to check -12, 6. Okay, so if we put in x equal to -12, y equals 6, well, that's a solution to the first equation because y equals 6. Second equation, that would be -12 is equal to -2 times 6, and that is also correct. So that's true. This is a solution. So let's go to number 8. 4x plus 5y equals -7. And the second one is -8x is equal to 3y minus 1. And they want us to check 3/4 and -2. Okay, so if we plug in x equals to 3/4, 3/4 times 4, that would be 3. 3 minus 10 is -7, so that's correct on the first one. Now on the lower one, that would be -8 times 3/4. That will be -6. So the 4's will cancel. 4 cancels 8, turning the 8 into a 2. 2 times 3 is 6. That's -6. Let's just write that out. Okay. That is that becomes a 2. That's -6 equals -6 minus 1. That is not correct. So this is not a solution. And that's number 8. Okay, now let's go to number 10. It says that you've given the equations 2y minus x equals 8 and x plus 3y is equal to 11. And what they're asking for here is solve this solution by graphing. So they're going to graph two lines and find where the intersection is, approximately. Then we'll have to plug it back in. Okay, so let's see. We'll use the intercept method. On the first one, when x is 0, y is -8. Okay, that's -8. Looks like I had something on 5. Okay. Now on the first one, when y is 0, x is equal to 4. So the first one, equation A, produces a line that looks like this. Second equation, which we'll call B, when x is 0, y is equal to 11 divided by 3. That's 3 2/3. 1, 2, 3. That's somewhere up here. Okay. And y is 0, x is 11, so that's going to be somewhere out here. So that's going to be something like this. Now, my plot is not very accurate, so this indicates that there will be a solution somewhere in the vicinity of 6 and 2, more or less. But honestly, it's going to be a tough call here. This is not accurate graph paper. So I'm just going to have to say, I'm just going to guess to check 6, 2 and see what happens. If x is 6, that's 12 minus 2 is only 10, so that is not a solution. So I can't really solve this very well by graphing. On the second one, it would be 6 plus 6 is, that would be 12 instead of 11. Seems like my x needs to be a little bit bigger. Boy, they didn't make this easy, did they? Oh, my y needs to be a little bit bigger. Yeah, I'm afraid I'd have to use accurate graph paper. So what I'm going to do is I'm going to take a pass on this one. And what I'm going to do is actually solve it by another method. Okay? Since I can't draw these accurate enough. I know it's somewhere in there, but I can't guess. That would take too long. Okay? So what I'm going to do instead, solve it by another method. I know that it's going to be somewhere around here, but I don't know exactly where. Okay. Okay, sorry for the delay. These things are not spaced out very well. Okay. Well, let's see. How can I solve this? A couple ways to do this. First one, I could solve for y rather easily. Y on this one is going to be 2x minus 8. Because y is all by itself. And I can move that to the other side, 2x minus 8. I can then plug this into the second equation, and the second equation becomes x plus 3 times 2x minus 8 is equal to 11. This will solve for the value of x. This is x plus 6x minus 24 equals 11. Move that to the other side to get 35. 7x equal to 35, x equals 5. Okay, so that basically is going to do it. If x is equal to 5, then y has to equal, because 10 minus what? Y would equal to 2. So instead of 6, 2, it was 5, 2. It was, let's plug that in now to the second one. 5 plus 6 equals 11. Yeah, so that is the correct answer. I wasn't that far off, but it was actually there, because my grid was not spaced equally. Okay. So I'm afraid it's probably pointless to do all of these ones manually. I will have to replace them by a different method, actually. That's okay. 4x minus y equal to 6. X minus y is equal to 0. This one we can solve by elimination. We don't add these two, we subtract them. 4x minus 1x is 3x. Negative y minus y minus a minus y is 0. And 6 minus 0 is 6. So this is x equals 2. If x equals 2, then y equals 2, based on the second one. So I solved it algebraically rather than graphing it. That was number 12. Number 14, negative x plus 3y equals 6. 3x minus 9y equals 9. Same deal, I'm going to want to solve this. Do a different method. Now, I happen to like the elimination method a lot. And the way I can do it on this one is I can multiply the first equation through by 3, then add it to the second one. If I multiply the first equation through by 3, this becomes a 3, this becomes a 9, this becomes 18. Then I can add the 2. Whoa. Add the 2 and I get 0 equals 27. So this is one of those tricky equations where we're not going to have a solution. Let's go back to the original equation. I think we'll see why. Okay, it was the original equation on top before I multiplied by 3. It's negative 3 plus 3y is equal to 6. Is that right? Yeah. Okay. I can see that these two equations are going to have the same slope. There's not going to be an intersection on these ones. So, and that's what, when we tried solving it by elimination, we didn't get us an answer. So if we solve the first one in terms of y equals mx plus b, this is going to be y is equal to 1/3 x plus 2. I move the x to the other side, divided by 3. This has a slope of 1/3 with a y-intercept of 2. Now the second equation, I can solve this by y by moving the y over to the other side, moving the 9 over, dividing by 9. I'm going to go y is equal to, divide through by 9, that's 1/3 x. Okay. Minus 9, so this is going to be minus 1. Right? I'll just do those steps out. Move that to the other side, it's going to become 9y. That's going to be equal to 3x minus 9. And that's going to be y is equal to 1/3 x minus 1. This also has a slope of 1/3, but it has an intercept of -1. So there are two lines here. They both have a positive slope of 1/3, but one has an intercept of 2. The other has an intercept of -1. They are never going to intersect with each other, so there's no solution to this. And this is one of the categories that they have a name for putting these into different categories. This is going to be, what are they called? A inconsistent system with independent equations. So, inconsistent system, that's just another way of saying there's no answer. Okay. Okay, now, let's go to the next one. Y equals negative 2x, negative 3y is equal to, plus y is equal to 10. Okay. Oops, negative 3x plus y is equal to 10. So, assuming that there is a solution, we can obviously, we've got the first equation, we can substitute from the first equation to the second. That'd be the easiest way to get a solution here. And we're going to get negative 3x, plug in minus 2x equals 10. That's negative 5x equals 10, or x is equal to 10 divided by negative 5, and that's a negative 2. So if x is negative 2, then y is equal to 4. So that's definitely a solution to the first one, and we can plug that in for the second one. That would be negative 3 times negative 2, that's positive 6. 6 plus 4 is 10, so this is correct. Solution. Okay, we even double checked our work. Okay, now, that's the end of the ones where they want us to plot. So I think we can erase this, we won't need this anymore. And we weren't able to plot that accurately enough anyway. Now they want us to use the substitution method to solve these. So we'll just go to that. 5x plus 2y is equal to negative 17. The second equation is x is equal to 3y. So what we're going to do is, where we have x, we're going to substitute it in the first one. So we're going to take the x away, substitute it by 3y. Okay? Now we've used the second equation. Now we just have one equation. It's 15y plus 2y equals negative 17. That's going to be 17 times y is equal to negative 17, or y is equal to negative 1, dividing both sides by 17. Now, if the y is negative 1, then we can see that the second equation was x equals 3y. I guess I shouldn't have erased that so quickly, because that allows us to get the x is equal to negative 3 more quickly. Okay, that's using substitution. Okay, might have gone off scale there. Okay, let's go 3x. This is number 20. Minus y equal to 6. Minus 4x plus 2y is equal to negative 8. Okay, now we're going to use substitution. So we're going to solve the first one for y. I'm moving the y over. That's going to be 3x minus 6. We're going to plug that into here. So let me just write down the modified second equation. 4x plus 2 times 3x minus 6. That's just what we got for y on the first equation. That's equal to negative 8. Now we just solve for x. So that's negative 4 plus 6x minus 12 is equal to negative 8. Or that's 2x is equal to plus 4, or x equals 2. And if x equals 2, then y is equal to 0. We get that by just plugging back into one of these equations, like the first one. That's 6 minus y equals 0, so that means y is equal to 0. Okay, and this was on a test. I would also plug that into the second one just to make sure that it is a correct answer. Okay, but I won't do that in the interest of time on this one. Okay, that was number, let's see, which one was that? Oh, that was number 20. Okay, number 20. Now we'll go to 22. 22, that's 2/5 x plus 1/5 y equals negative 1, and x plus 2/5 y equals negative 8/5. And this is substitution, so I'm going to use the second equation because I can readily solve that for y. I'm going to plug it into the first equation. Okay, for x, so what I'm going to end up with is 2/5 times x, but I'm going to use what I got on the second equation here, and that's negative 2/5 y minus 8/5. That's what I got by moving that to the other side, plus 1/5 y is equal to negative 1. Now I'm going to solve this for y. And I'm going to, first of all, I'm going to multiply it through by 5. Multiply through by 5. That gets rid of this, and it gets rid of this. So I just have a 2. Okay, that makes it a little bit simpler. And I'm going to group like terms now. I could multiply through by another 5, and that would clear out this. So for example, if I multiply through by 5 again, I get rid of the 5's on the bottom. I put a 5 here, and this is negative 25. Okay, see how I did that? These things, I'm going to rewrite them just so they look better. This is negative 2y. That's clearing out the fractions. Okay, now this is negative 4y minus 16. Okay, plus 5y is equal to negative 25. Now this is just equal to y. It's equal to negative 25 plus 16. Okay, and that's equal to 9, or negative 9. So y is equal to negative 9. Then we can plug that in up top to get x. And I guess this bottom one would be the easiest one to do that. Oh, okay, so what we get there is x I'll just do that right here. X is equal to negative 2/5 times y, which is equal to 9 minus 8/5. Okay, so 2 times 9, that's 18. We can put this all over a common denominator, 5. That's going to be 18 minus 8. That's going to be equal to 10/5, which is equal to 2. X equals 2. So y equals negative 9 and x equals 2. So this can get a little bit messy. And that's why these are called exercises. It's hard work, and it can be draining you. You have to focus in order to not make a mistake while you're doing all this. And you do need to practice this in order to get good at it. Okay, let's see, which number was that? Let's see, is that number 2/5 one? Okay, that was number 22. So we're on to 24. 24, x equals 3y minus 1, and 2x equals, 2x minus 6y equals negative 2. Okay, we're using the substitution method, so we've already got x solved, so we're going to plug that into the second one. It's going to be 2 times 3y minus 1 minus 6y is equal to negative 2. Now this is going to be 6y, and you're going to subtract 6y. So what's going to happen is this will produce no solution, because what this equation is producing is 6y minus 2 minus 6y is equal to negative 2. Or negative 2 is equal to negative 2. Well, that's correct, but it doesn't give us a value for y. And what happens is when we look at that more carefully, what we see is that these two equations are dependent on each other. If we solve this second one for x, it becomes x is equal to 6y minus 2 divided by 2, and that's equal to 3y minus 1. In other words, this second equation is really the exact same as the first equation. It's dependent. This is called the case of dependent. One equation is dependent on the other one. In this case, it's the first one multiplied by 2. Okay, it's the same equation, essentially. So if you plotted this as two lines, there's two lines. There'd be two lines, they'd be right on top of each other. So there's an infinite number of solutions. Any value of x, not any xy pair which is on this line will be a solution of both equations. So there will be an infinite number of solutions. So when they say what is the solution set for this, it's going to be an infinite number. Okay. So I don't think an infinite number of solutions. So I would say, I'm not sure how they want you to express that. One way we'd be expressing would be the solutions are x and y. The solutions could be expressed as 3y minus 1 and y for any value of y, because that would be the x coordinate. For a value of y, for a y coordinate of y, the x coordinate is 3y minus 1. This would be a solution of both of these equations for any value of x. Okay. But all they might want to know is that there are an infinite number of solutions, rather than to actually list. You can't list an infinite number of solutions. So, okay, that was number 24. Now we're going to use the elimination method instead of the substitution method. I normally prefer the elimination method. I like it. And here's how it works. 2x minus 3y equals 0. 2x plus 6y equals 3. Okay, now the idea here is to combine the two equations to eliminate them. And the way we're going to do it is we're going to subtract the second equation from the first. 2x, so we're going to subtract it term by term. if we subtract 2x minus 2x is 0. Negative 3y minus 6y is minus 9y. 0 minus 3 is negative 3. The idea is, if this is equation A and this is equation B, this left-hand side is equal to this right-hand side. This left-hand side is equal to this right-hand side. If we subtract these two, they're going to be equal to the difference of these two. So these two subtracted will be those two subtracted. So that's a valid equation. And it's equal to y is equal to 1/3. Okay, now if we plug in y is equal to 1/3, this will be negative 1, which is going to be positive 1 on the other side. So the x is going to be 1/2. And we can plug that in and see that x is 1/2. 2 times 1/2 is positive 1, minus 3 times 1/3, that's negative 1. Positive 1 minus negative 1 is 0. And we can see that that is the solution. Okay, that's number 26. So you can see this is hard work. 6x minus y equals to negative 5. 4x minus 2y is equal to 6. Okay, now we're going to be using elimination method. So what I'll do is multiply the first equation by 2, because that makes these the same, and I want to eliminate a variable. If I multiply the first equation by 2, okay, it's going to become 12x minus 2y minus 10. And the second equation is 4x minus 2y, equals negative 10. Okay, and this next one is just the equation itself. Okay, now I'm going to subtract the two. 12 minus 4 is 8, 8x. Negative 2y minus negative 2y is 0. And negative 10 minus 6 is negative 16. Okay, so x equals negative 2. Now I want to go plug, I have to plug back in and solve for y. So if I put in negative 2 to one of these equations, let's just use the first one. 6 times negative 2 is negative 12. Negative 12 minus what is equal to negative 5. Now negative 12 minus 7 is equal to negative 5. Y is going to be 7. Okay. I did that, in my head. I could have written out more about that, but I could move that to the other side. Becomes a positive 12. 12 minus 5 is 7. I'm sorry. Let's put that in there. X is negative 2. So this is negative 12. Move that on the other side where it becomes positive 12. Positive 12 minus 5 is positive 7. Negative y is equal to positive 7. Y is equal to negative 7. Oh, negative 7. Yeah, I guess I'm glad I checked it. Come up with a negative 7. So now what we'll do is plug those in just to double check. 6 times negative 2 minus negative 7 is equal to negative 5. It's negative 12 plus 7 is equal to negative 5. Okay, and that's correct. So I actually made a mistake by doing it in my head. So it's not always a good idea on a test. You can try doing it, but I did check my answer afterwards and found out that it didn't check out. So I corrected it. Okay? Anyway, let's see. That was number 28. So now we're on to number 30. 3x plus 4y equal to 2. 2x plus 5y equal to negative 1. We're using the elimination method, so we want to combine these to eliminate a variable. Now, you look at this right off the bat, it's not going to be obvious how to do this. So what we're going to do is, we're going to multiply the first equation by 2 and the second equation by 3. The idea is I'm going to subtract the x's. So if I multiply the first equation by 2, that's going to be 6x plus 8y is equal to 4. I multiply the second equation by 3, that's going to be 6x plus 15y is equal to negative 3. So you see what I was trying to do is get these ones to match up. Now when I subtract them, I get 8y minus 15y. That's going to be minus 7y. And I get 4 minus a negative 3, that's equal to 7. So that means y is equal to negative 1. Okay? Now, if y is equal to negative 1, let's go and solve one of these equations by putting in the negative 1. 3x minus 4 is equal to 2. Or 3x is equal to 6. Or x is equal to 2. That's equal to the answer, and let's just plug that in. That would be 3 times 2 is 6, minus 4 equals 2, so that looks correct. Okay. And that was number 30. Okay, now we're on to 32. 6x equals 3y minus 3, and 4x equal to negative 5y minus 9. So this is the same category that we can't just add or subtract these right off the bat to cancel. We have to multiply one of them by one thing and the other by another. So in this case, let's focus on the 3 and the 5. Okay? I'll multiply the first equation by 5 and the second equation by 3. And that's going to allow me to cancel this. So I multiply the first equation by 5. That gives me 30x is equal to 15y minus 15. Multiply the second equation by 3. That's going to be 12x is equal to negative 15y minus 27. Now I'm going to add the two equations to cancel this term, and that's going to give me 42x is equal to, and it's going to be a negative 42. How convenient. Okay, and that means that x is equal to negative 1. If I plug in negative 1, then I can solve for y. So let's use the first equation to do that. Negative 6 is equal to 3y minus 3. Or, bring the 3 over, negative 3 is equal to 3y, or y is equal to negative 1. Oops, negative 1. So let's check it. Negative 1, so it'll be negative 6 equals negative 3 minus 3. So negative 1, that is a solution. Okay. That was number 32. Now we're on to 34. Also using the elimination method. I might have run off the bottom there. I erased it. I'm sorry, I didn't check. Okay, on to 34. Okay. Negative x plus 3y equals 6. And 3x minus 9y is equal to 9. Okay, now this one is going to be easier for elimination because if we multiply the first one by 3, it's going to allow for cancellation. So if we multiply the first one by 3, we'll get negative 3x plus 9y is equal to 3 times 6, or 18. And we'll just write the second equation down again. Oh, I see we're going to run into a problem because we're going to cancel both of them. These equations are they look dependent. It's not going to be a solution to these. These represent two parallel lines. So y equals, if we look at the slope of the first one by solving for y, we'll get y is equal to x plus 6 divided by 3. We solve the second one for y, we're going to get y is equal to negative 3x plus 9 divided by negative 9. And that's just x over 3 again. So the slope of both of these is 1/3, and they have different y-intercepts. These are independent, but there's no solution. It's an inconsistent system because these are parallel lines. Okay? Well, I could see this when I'm doing this because if I try to eliminate one variable, I end up eliminating both. So this method of solution fails. It fails to produce a solution. The reason is because there is no solution. Okay, now we'll go to 36. Y is equal to 2x minus 5, 8x minus 4y equals 20. Okay, now we want to solve this by elimination. Well, when I do it by elimination, I like these things to line up. See, I'm going to get this 2x, I'm going to get the y on the other side and 5 over there. So I'm going to rewrite the first equation so that it actually reads 2x minus y equals 5. See, I just moved things around. And that's the same as the first equation rewritten. Now it's in the form that's easier to see. Actually now, if I multiply the second equation by 4, you can see that that's going to be 8x minus 4y equals 20. It's exactly the same. These equations are dependent, so these are two lines are right on top of each other because this first equation and the second equation are dependent. The second is really the same equation. It's the first equation multiplied by 4. It has the same solutions, the exact same solutions. Okay, so that one has an infinite number of solutions. Okay, 2x minus y. That was number 36. Okay, number 36, we're on to number 38. Okay, this one, it says solve by substitution or elimination, so whichever method you like. X minus 4y is equal to negative 5, and negative 3x minus 8y is equal to 0. Okay, so which is the method that we're going to want to use? Well, I like using elimination unless the substitution is a very easy implementation. Now, we do have x all by itself, so it is easy to solve for x. So let's go ahead and use this substitution. We'll take negative 3. I'm going to plug in x. That's just 4y minus 5. Then it's minus 8y equals 0. So I took the second equation, took the first equation, solved it for x, plugged into the second one. That's going to give me negative 12y minus 15 minus 8y is equal to 0, or minus 20y is equal to 15, or y is equal to minus 3/4. Okay. Now we can plug in and find x. Y is equal to negative 3/4, then negative 4 times 3/4 is the same as positive 3. So let's just solve this one for x. We already have it. X is equal to 4y minus 3. 4y minus 5. Okay, and that's going to be equal to 4 times negative 3/4 minus 5. It's negative 3 minus 5 equals negative 8. Okay, is that too low? No, I guess that just made it on. Okay. Negative 8. 4x. Okay. Let's just plug that in. Into this equation, that would say negative 8 plus 3 is equal to negative 5. And that seems okay. That is too high to see, but when I plug those numbers in, I got that equation okay. Okay, so That was, oh, that was number 38. That was actually the last one. That was good, because that was a little bit tiring. And after a while, you can make mistakes after a while if you don't take a break. So, please leave any comments down below, and I'll see you next time.